Okay, well, let's see, last time, all these things that had to do with the straight line, slope, a lot of y equals mx plus b work. Given 2 points, find the equation of a line. Okay, questions on the assignment, or on that, on the last lesson? Yes.
For number 49, I came up with a different answer. So did I. We got the same answer with the book.
All right, let's take a look. That's the money one.
Yeah.
Oh, I happen to have that one here. Okay, let's see if I interpreted this right. In 49 and 50, you're given the dollar value of a product in 2003 and the rate at which the value of the product is expected to change during the next 5 years. Use this information to write a linear equation. Okay, so they told us that in 2003 it was worth $2,540. The rate is $125 per year. That really is your slope. So it's y equals mx plus b. It's really 125x plus some b. I know I wrote it, the 125t afterwards, but it could have been, I could have written it like this. Could have said, you know, thought of it like this. So when they gave you the rate, they gave you the slope. Now you have to take this ordered. Forget that for the moment. I took the rate, the value of this thing in 2003, and that's like an ordered pair, right? So what I did is once I had this equation down here, I simply plugged in 2540 for y and 2003 for x, and then I solved for b. And that's where I got this thing. So let's just quick do that, see if that works. So plugging that in, what do you get? You get 2540 equals 125 times 2003 and then plus b. Okay, what's 125 times 2003? What's that? Is that what they say?
Yeah.
Ah. Okay. That's the trouble with doing them real quick. So basically, this is a 3 then. Okay. And I'm not going to rewrite this up here. Okay. So that's what, 375? And then 2540 minus 375. And b equals 2165. Yep. Okay, well then I came back up here and I just wrote this. But I would have been just as happy with this, except that they wanted b. But it's really, you know, I would have accepted this answer. Is this the answer you guys were talking about that you had?
Yeah.
That's no different. I think this is what the book had over here to the left. Oh, so you use that as your y-intercept, 2540. Yeah, you had to, except that I should have just called this 3 here, up here. You had to substitute in your ordered pair to find it. Okay, another one. Yep, 81. Okay, 81. use the I gave you the x-intercept and the y-intercept. You're supposed to find the equation, and I will just use slope-intercept. So you have 2, 0, and 0, 3. So basically, haven't they just given you those 2 points? And you're supposed to find the equation. Step 1, find the slope. I got to put the number down. This is 81. Okay, y2 minus y1 over x2 minus x1. I got to make a decision here on which one's 1 and which one's 2. I'll just go like this. So y2 minus y1 over x2 minus x1. I get a positive on the top and a negative on the bottom, so I know it's a negative, so negative 3/2. So now I know my equation begins y equals negative 3/2 x plus b. And now I have good news for you. Haven't they already given you the y-intercept? They handed it to you on a silver platter, so you don't even have to calculate. So in slope-intercept form, this would be your answer. Now, they asked for a different form. I think I told you, I always want you to go slope-intercept with everything. So what did they ask for? Yeah, I don't even know quite what that means, but this would be great. Okay. I've been leaning on this side. Are there questions from over here? Yes. 80, which one? Okay. All right, number 85. They gave you a point. They gave you the x-intercept and the y-intercept. Okay. So I got them all up there. Here's the point. We know it goes through. We know its x-intercept is interesting, c comma 0, and the y-intercept is 0 comma c. All right, so what I did is I took these two guys and I calculated the slope. You wouldn't have had to begin this way, but I called this point 2 and this point 1. Did my slope formula. C minus 0 over 0 minus c. C over negative c. So I know my slope is negative 1. So right off the bat, I know this. And now, all I need is the y-intercept. I need a point. Now I need a complete point. These are kind of incomplete. This is a complete point with both numbers. I plug that in. 2 for y, 1 for x. And now I know b. And so I got it all now. Yes. Those 3 things on the top there were all given. Correct. That was a unique way to give it to you, wasn't it? They kind of half gave you each of the intercepts. The cool thing is they both had a c in them, so that allowed us to still calculate the slope. So there's 85. So we can maybe go through a couple more if you want to. Yes. 93. Okay. This time we're given what? A point and the line. Oh, and you got the 2 parts, parallel and perpendicular. Okay. Which one is it? I got the part, now I lost the number. Okay, 93. We have 2 comma 5. And the line is, thank you. So that's a vertical line, isn't it? Oh, this one's going to be pretty easy. So what's, you can't even give me the slope of this line because this is an undefined slope. It's a vertical line. But for the parallel part, all lines parallel to x equals 4 are x equals, all these different numbers. X equals 10. Any x equals number is going to be a vertical line. So which x equals number goes through this point? So that's the end of that one. And part B, what kind of line would be perpendicular to that? A line whose slope is 0. Oh, so that's y equals 0x plus, or in other words, just y equals. So it turns out that one you could have done with actually no algebra at all. So it was a little bit weird in that it had this undefined slope, but the good news is you already know all vertical lines are x equals something and all horizontal lines are y equals something, so they kind of handed that one to you. So I know what I wrote up there probably didn't do any good because I didn't calculate, I just used my reasoning to do it. Another one? Yes. 105? Okay, 105. Cash flow per share. The cash flow per share for Timberland Company was 18 cents in 1995 and $3.65 in the year 2000. Write a linear equation that gives the cash flow per share in terms of the year. Let t equal 0 represent the year 1995. Okay, so they want that kind of to be the year 0. So therefore, wouldn't one ordered pair be 0, 18 cents? And wouldn't the other one be 5, 365 using that coding? If year 0 is 1994, on 1995, then wouldn't year 5 be the year 2000? And now, how do you find the equation of a line given 2 points? Same old deal. Step 1, find the slope. I found that to be negative 0.694. Now, put your slope in the m position. All you got to do is find b and you're done. Plug in one of the 2 points. I'm trying to figure out which point I plugged in. Oh, I didn't have to. Why not? Because they gave me the y-intercept. Look, whenever they hand you the y-intercept on a platter, you should accept it with a smile. So there's my y-intercept, so I just plugged it right in. And I believe is that what they wanted you to find? And then did they want you to make a prediction? How does the rest of that go? Yeah. So anyway, that's A. Part B, use this equation to predict the number of units when the rent is $6.55. I'm in the wrong place. I went to the wrong problem. This is 105. Predict the cash flow for the years 2005 and 2010. Well, 2005 is when X is what? $10. And then 2010 is when X equals 15. So all you have to do is plug in 10 and 15. I see I plugged in 15 on the bottom there. What happens when you plug in 10? What's 10 times anything that's decimal? Just move the decimal one place over. And then all you got to do is add, and it comes out to 7.10. So there's my prediction for 2005. And for 2015, or 10, X is 15, plug in 15, calculate it out, and you have your prediction. Anybody, is that enough information for, okay. All right. I'm collecting your assignments today. So, try to get them together. Put your initials on each page or something. Okay. I know I haven't collected assignments yet. Here's my first one. don't know what we'll do. You're obviously two. Yes.
Yeah, I went 85, 87, and then 300.
I wouldn't worry that much about that. I'm more interested that you did the right number of problems, and you probably did. Yeah, if you get a little off, somebody was worried here that, you know, they did every, you know what I mean? They went from 85 to 87 instead of 89. Is that going to mess up the rest of your assignment? Honestly, I'm not that upset that you did different problems. Oh, but you gotta take that responsibility. What you do is you haven't done it at all. Oh. I would say the quicker the better. I might be able to do what you said. So if you could try it, I know you got fuzzies on there and everything. Don't worry too much about that. I don't have a stapler, so just kind of bring them as close and put your initials maybe on the subsequent pages, and then send them to the center aisle. I will. Why don't you do this? Since we don't have staples, would you cross-file them? You know what I mean by that? Just turn them 90 degrees, and that way we can stay a little bit better. Okay. Well, let's get going here on new lesson. 2.2, Introduction to Functions. Okay, this is a real foundational section. So much is based on the concept of functions this year. This is really a huge one. We have the following 4 objectives. First of all, you notice the word relation is in the title, so we're going to have, even before that one, you got to know what the difference is between a relation and a function. I will talk about that. And once you know that, you got to be able to tell when relations are functions and when they aren't. Number 2, you got to be able to use function notation and evaluate functions. Number 3, find the domains of functions. Number 4, word problems. So we're going to have to, so maybe the first thing we should talk about are relations. And I don't know, yeah. So right off the bat, this talks a little bit about that. What's a relation? A relation is a set, it's really any set of ordered pairs. Okay? Is the way I would put it. Any set of ordered pairs. And I want to emphasize the word any. Have you ever heard somebody talk like this when they say, you know, what kind of requirements do you have for that position? You know, what are the prerequisites? And every once in a while somebody will answer and say, well, yeah, the person has to have a pulse. And what are they, in a sarcastic way, what are they saying? Oh, we'll take anybody who's alive, okay? That's what you call low requirements, okay? Now, that's kind of how a relation is. If you take any old set of ordered pairs, I don't care how random they are, any set, whether there's a pattern or not, that is a relation. So this is like, this is not a very high requirement. This is like saying it's a set of ordered pairs that has a pulse. Any set will work. The fussy one is when we get to a function. Okay. We always represent relations with ordered pairs. You know how that works, x comma y. You guys were working with ordered pairs today, weren't you? We gave you 2 points and we said find the equation of the line containing them, and you had sets of ordered pairs. Okay. Now, this is the picky one, a function. And the important thing, this is maybe a little too formal, but it says go from set A to set B. We're going to give you a point. We're going to give you a number and say, here's the rule. Multiply by 16 and add 4. Okay, that would be y equals 16x plus 4. Does that sound familiar? That's a straight line equation, right? Y equals mx plus b. Multiply by 16 and add 4. And in a way, that's the rule that we use in that case. The rule has to work in this way, that whatever rule I give you, only one answer will come out. So that shoots absolute value. No. That shoots this one. Let me give you an example. This one's got a problem. Okay, if we solve this for y, what would you do? Square root? Tell me a little bit more. You need to tell me a little bit more.
Square root y squared is x. Plus or minus.
Ah, there we go. You got to take both square roots. Thank you. And that should tell you something. Is there only one answer here? No. So this is not a function. There's got to be a rule where only one answer can come out. Now, if I said to you, multiply by 16 and add 4, is there any way you could get more than one answer from that? No. If everybody multiplies by 16 and adds 4, there's only one answer you can get, right? There is no double branch like that. Okay. So, you know, what it amounts to is functions are the nicest behaving equations, okay? The ones that are the best for algebra students to study because they only work one way. And so this is kind of like, when we deal with functions, it's kind of like saying, you know, you guys are just learning how to swim. So we're going to kind of be right next to you when you go in the water for the first time, and we're going to make sure you don't drown, okay? So we're not going to put you in the wave pool that has 20-foot waves coming by because you already had big eyes when I showed you the water, okay? So what we're going to do is we're going to put you in this baby pool, and we're not going to let the waves come at you. And if you get a real scary look in your face, we're going to help you out of the water and you'll be safe. So functions are nice behaving with no waves coming at you, okay? Later, when you guys are really good swimmers, then we're going to throw these non-functions at you and you'll be so brave you won't have any problem. All right. Now, so here's the important thing about a function. Whatever the rule is, it will only result in exactly one solution each time, as opposed to that guy right there, or of that type. By the way, here's another one. What about this one? Isn't this going to result in two different answers too? Because you're going to break it into two branches. So this is a non-function also. Okay, you get the idea. All the possible values that we begin with are called the domain. They're really all the x-coordinates. All the answers we get are the y-coordinates. Are called the range. So we're going to have this massive collection that looks like this, where when we give it a number for x, There will only be one answer possible for y, and all these kinds of things that x can be are called a domain, and all the things that y can be are called a range. Okay. Sometimes this is pictured this way. You got your domain over here, all the different x's, and you follow the rule, whatever it is, and out comes your answer y. Okay? So there's no significance to these crossing over. The point is, these don't have to be in a special order, but here's what's important. Each x has to point at only one y. If this pointed here and here, it wouldn't be a function. This is good. Each x goes maps to one y. That's a function. And these guys over here is the domain. These guys over here are your range. By the way, how does it look on a graph? Where the x-coordinates are, isn't that just telling you, hey, where are we left and right wise? And isn't the range just saying where are we up and down wise? Okay. All right. So here's a set of ordered pairs. By looking at the set, you should be able to tell me if it's a function or not. So here's the deal. For a certain number x, is there only one answer y? We don't even have any repeat x's here, do we? All four of these x coordinates are different here. So there's nothing to worry about. But if you look down here, you see how there are 2 points that both begin with -1? And look at, they gave us two different answers. One of them came out with an answer 1. One of them came out with a -1. That's a violation of what a function is. Remember, functions can only, for each number, can only have one result. So do you see why this is not a function and this is? Actually, I'm going to be showing you today what? I'd say at least 3 ways to tell if you have a function or not. One of them is this one. Just looking at a list of ordered pairs, can you tell me if you have a function? Why is this one okay? Because I never have some number that comes out 2 different ways. Why is this not okay? Because I do have a number that comes out 2 different ways. That's a violation. Okay. Yes. Right. Remember, if they have the same x, they can't have a different y. See, in that first set, none of them has the same x coordinate. So we don't have a problem. But here, see, these are duplicates, -1. Now, it would have been okay if this said -1, 1, -1, 1. It's kind of stupid to repeat it, but it would have been okay. But because 1 comes out one way, you know, that's like, by the way, let me give you a good example. I mean, we live with functions. We're so used to them. You're going to think this is silly. Picture this. Let's say Melody and I go down to the nearest grocery store down here, okay? And we both buy exactly the same item. I don't know, a gallon of milk. What does a gallon of milk cost? A lot. $3? All right, let's say you go through the line, Melody. They say, hello, you owe me $3. You pay, you leave. I come, I'm right behind you. I have exactly the same item. She rings it up and she says, $5.50. Okay, now that's not a function. And we would never stand for that because that's called, I mean, you can't charge one person one thing and another person another thing, right? That's totally incorrect, unfair, or whatever you want to call it. So, a function says, if we have the same item, you've got to charge me the same amount. You see how these guys had the same item and they changed, you know, you can't do that. You shouldn't be able to do that. So, okay, notation. Why don't we just go right down to here? How many, I think all of you have seen this before. F of x may have bothered you in the past, but it's very important notation. It's called function notation. and it's used in place of y. So instead of y equals mx plus b, we might just say f of x equals mx plus b. It's the same thing, but it has some advantages to it. Let me show you what they are. Let's see. Let's take an example of one we had today. I'll put it right on here so it gets recorded. I don't know. I think we had one. I'll just make one up, but it's of this type. Okay, that's in slope-intercept form, right? That's exactly the same as y equals mx plus b. And what is my m? 2. And what is my b? 1. Okay. Now, what's cool about function notation, instead of putting a y here, is I could say to you, find f of 2. And you notice, what did I do? I literally put a 2 in place of x. Does that tell you what to do? It says, put in 2 for x. And that's what I love about it. It's just like whacks you right between the eyes exactly what that means. So what is f of 2? 5, right? You guys are worrying me. 2 times 2 plus 1, all of you should be able to do that in your head. That should be 5, right? Okay. Good. Now here's what else is cool. F of 2 is 5. Look, that really means when you plug in 2, out comes 5. And isn't that a very familiar notation too? You see how beautiful that matches? F of 2 is 5, 2 comma 5. What's f of 0? You bet. And what is that? What's the ordered pair for that? 0 comma 1. So isn't function notation wonderful? It shows you exactly what they want you to substitute, and it gives you the ordered pair. It's a perfect match. Now you might get ones like this, and this is going to maybe bother you a little bit. What's f of a? Well, yeah, thank you. 2a plus 1. That's exactly correct. We can't calculate this one any better than that because we don't know any more about a. But what's the ordered pair for that point? A, comma, 2a plus 1. Okay, this is some of the cool stuff about function notation, and it's very, very important as we move forward. So this is just reminding you that, when I did f of 2, what we were doing is making 2 the input. When we plug in 2, out came out 5. So the function was 2x plus 1. The input was, I said find f of 2, so the input was 2, and the output was 5. So it's like in, out. X coordinate is what you plug in. The y coordinate is the answer that comes out. I can't resist. I got to show you something I wasn't planning on showing you because it really fits well here. Okay, so just give me a second. I got to find it. Okay, now you're going to think this is corny and everything, but that's okay. It really does a good, I think, hit the point. I don't know, when I was, long ago, one math book I started teaching with was trying to teach students what a function looks like. And you may have seen math books that do this. They make a little box, and the idea here is you put a number in here. Then in here, you can't see it right now, is some kind of a rule or a machine that does something, and then it spits out the result. So it's like input, calculate, output. That's a good picture of a function. I have some things to show you here. Okay. What I'm going to do is start plugging in numbers. And that red shield is covering up what the function is. I'm going to put some numbers in. You're going to watch the answers come out. See if you can tell me what the function is. This is really crude animation, okay? The 2 is slowly going in. Processes it. Okay, now do you notice in the top right corner, I'm keeping track of this. I plugged in a 2 and out came a 7. Now, I know you can't tell yet, so don't guess. But now we'll put in another number. We're going to put in a 1. Out comes a 4. Now you might be able to start guessing what's going on. I'll do one more, though. What happens when we plug in a negative 2? Out comes a negative 5. So now the question is, can you tell what's behind the shield? It's take the number I give you, triple it, and add 1, right? See, if you triple 2, you get 6. Add 1, 7. What happens when you triple this? Negative 6, add 1. Yeah, see, this works. Okay? So, you found this. Okay, next. What's the function? In goes a 3. Oh, this is a tricky one. Out comes a 3. In goes a negative 1. Out comes a negative 1. In goes a 9. Out comes a 9. What's happening? F of x equals x. This is like saying, I got to tell you, this is what happens to me when I go to a doctor's office. First of all, I'm a cheapskate. And I don't go to the doctor until I absolutely have to. Okay, I'm practically dying. I finally go, all right, I'll go to the doctor. And I can't breathe very well. You know, I got this sore throat. And I go in there. I wait an hour in the waiting room. This is typical. You come in, doctor does a few things, and he says, you know what? You've got a sore throat. That'll be $100. Like, duh, I knew that before I went in. And of course, then he gives me drugs, and that goes real well with my booze. But anyway, you get the idea. So it's like the doctor tells me I'm sick. Don't you love that? And then they get to charge you. I should have been a doctor. I am a doctor. But anyway, like was stated up here, it is an X. Okay, sorry. Now here's my picture of what's going on behind the scenes. Okay, you see what it amounts to is whatever you plug in, you just lubricate these sides and let that baby slide right through, right? Don't do a doggone thing. Just tell the patient, you know, he's got a sore throat. All right, now, this is normally called the identity function. Why? Because you get the identical thing out that you put in. Okay, I like to call it the lazy man's function because you do absolutely nothing. All right, now, ready? This is my masterpiece on this. I can't believe I spent time on this, but here we go. Plug in a 3, out comes a 3. Okay, now that's different this time, I promise you. Plug in a negative 1, out comes a 3. Okay, plug in a 9. Yeah, somebody guessed it back there. Out comes a 3. Now what function is this? F of x equals 3. Yeah, exactly. Now, there's a special name for this, too. This is called a constant function. And this reminds me of my medical experience when I was in college. And honestly, it does. I got to tell you. We had a school nurse. I've been to her for various things. I'm not that kind of person where I go to doctors. I already told you that. But I don't know, see, one time I was having trouble breathing. Actually, turns out it was really serious. I had to be hospitalized. But anyway, I had tonsillitis and 3 other things at the same time. But anyway, the nurse said, here's what I want you to do. She looked at me and she said, you get a lot of bed rest, drink a lot of fluid, and chew Aspergum. It's like, I don't know why, Aspergum. It's like, I don't know why, as an adult, I couldn't take any aspirin. But anyway. Then, on another occasion, I had been to the doctor to have some growth removed or something, it's just a minor thing. But the doctor messed up and I wound up with a streak down my arm for blood poisoning. So I go to show the nurse and she says, all right, here's what I want you to do. Get a lot of bed rest, drink a lot of fluids, and chew Aspergum. I'm not kidding you. I don't care what you had. If you were decapitated or if you had a sore toe, the same doggone prescription was get a lot of bed rest. I don't know how you would do that with your head off, but get a lot of bed rest. Okay, that's a constant. Okay, now, I spend time doing this. Here's my picture of what's going on. Okay, as you plug in a 3, in effect, I don't give a rip what you gave me. Notice we throw that away, and out comes a 3. You plug in a 9. So, in effect, we don't even give a rip what the guy's putting in, right? You get it? Okay, actually, this isn't a bad way to learn functions, except I know I spent quite a bit of time on this. Now, officially, this has a name, and you're going to have to know it in this class. It's called a constant function. It's saying, I don't care what you gave me, you are getting, and then whatever it is. I rather, what? Not so politely call it the I don't give a rip function. It basically says, I don't give a rip what you give me, you are getting a 3, pal. Okay. Okay, there's my little function machine. Thanks. Anyway, I just wanted to show you that because that's exactly what we're talking about. Input, output, and by the way, there are certain ones, like the constant function and what? The identity function that we had a few minutes ago. Those are going to be part of this chapter. Okay? So I've already shown you this, but how do you do an f of like -2? If this is the function, how do you do an f of -2? Answer? Just look at what we did. We plugged in a -2 where there was an x. So that's what you do. Wherever there's an x, you plug in a -2, and you do your arithmetic, you finish it up, and smile. And when you're all on the bottom line there, f of -2 is 9, you've really got an ordered pair on your graph. -2, 9. Now, look at this one. I had you do f of a. This is important. What if I ask you to find f of x plus 2? Well, what did I do? In place of x, I put a x plus 2. So what does that tell you to do? Wherever there's an x, I have to now replace it with an x plus 2. So I just did that. Now, of course, there's a little bit of work that has to be done here, especially over here. This is a ding, ding, dinger, right? It's going to have a middle term. And, when you come down to it, simplify it, in this case, I can't come up with a number. So here, f of x plus 2 is 4 minus x squared. So here, this is an ordered pair too. It's x plus 2, comma, 4 minus x squared. Don't think this is what? Not unnecessary. This is really right at the heart of where we're headed in this lesson. Yes?
When you put in the parentheses for ordered pairs, x plus 2 comma 4 minus x squared, or do you
Yes.
put both in front?
No. Just like you said the first time. Parenthesis, x plus 2, comma, 4 minus x squared, parenthesis. So you just have some chubby coordinates. Okay. Yes. Sure. This is going to take, I knew this would take 2 days today anyway. So. Okay. Now the word domain. Remember, domain was all the x's. So the idea here is when you look at a function, like let's just take this one right here. And this is a good old straight line with a slope of 3 and a y-intercept of 5. This rule, this function, ask yourself, what kinds of things can x be? Actually, what you want to do is turn it around backwards. Is there anything x can't be? Is there anything you can't multiply by 3 and add 5 to? No. So the domain on this one is any number your little heart desires, otherwise called all real numbers. You see, this can become an issue when I give you one like this. What if I give you one like this? Whoops. What if I had given you this function? F of x equals 1 over x. Is there anything x can't be? Yeah, x cannot be 0. Is there anything else x cannot be? I don't think so. You can divide anything else into 1. And so, for a domain for this guy, you'd have to say any number except 0. So see how domain can become an issue. How about the domain on this one? F of x equals square root x minus 3. Is there anything x can't be? Well, now with real numbers, we're not going to use complexes now. Just think about the reals. I got a problem whenever there's a negative under a square root sign with a real number. So I can't have x be a number that would leave me with a negative under it. So x has to be at least as big as what? Doesn't it have to be at least as big as 3? Because if it's 3, it's still okay. 3 minus 3 is 0, and I know what the square root of 0 is 0. But if it's a 2, I got a problem, right? Or if it's a 2 and 2.8, I have a problem. So what are we saying? X has to be 3 or bigger. How would you write that in interval notation? Square bracket, 3. Infinity, round bracket. Okay. All right, we're out of time. I will continue next time. Assignment for Friday is get some sleep. I'm not going to give you anything else.